science fiction movie than a technical discussion. Please trust me, this isn't a gimmick to reel you in. It's not a gimmick at all. Our dedicated team of former scientists has been working tirelessly to translate all this intricate science of application security into bite-sized and actionable insights for everyone. Just picture this. I've been in this field for over 20 years. And yet, this recent discovery had even me raising an eyebrow in astonishment. And it's not just us, not just our Derscanner team, the broader scientific community of researchers, of scientists, has been buzzing about this issue too. So fasten your seatbelts and get ready for an exhilarating ride. The ride through the world of application security. And please, during our webinar, please feel free to actively participate by asking questions in the chat, because your engagement makes this session even more valuable. So let's get started. What's the agenda? We'll start from a bird's eye view of the application security landscape. And to get to the real core, real idea of this webinar, before that, let's soar above these conventional SDLC or application security practices and uncover these sneaky loopholes that might be just lurking in your security protocols. So today, together, we'll navigate these potential pitfalls, ensuring your application remains rock solid. Conventional practices or SDLC, you can usually describe them in a simple phrase, which is shift left. Ever heard of this? I believe yes. Because it's not just a phrase, it's our guiding star in the app security galaxy. Just imagine reviewing your code right after it's born fresh out of the developer's workshop. And this is the place where the magic of such tools like SAST, which is static application security testing, and SCA, which is software composition analysis, come into play. And as our application grows and takes shape, we bring in the heavyweights like DAST and penetration testing. It's like we are giving our app a superhero training regimen, ensuring it's ready to combat any threat possible during its life cycle. And the shift left concept is frankly, it's not only prudent, but it's highly practical, as it enables you to identify and rectify vulnerabilities in your system's development lifecycle at the very early stages. And in the realm of application security, the philosophy dictates that if you adhere to shift left practice, then you're on the right side. But at the same time, while shift left is undeniably crucial, it begs the question, is it really sufficient or not? So the question is true security guaranteed simply by following shift left practice? What if you have diligently eliminated vulnerabilities in your source code, practice shift left to the fullest extent possible, and essentially you adhere to all the standards of conventional application security practices? Let's assume that you have done all of this. Is it reasonable to find yourself with a vulnerable application after that? Is it reasonable that after that you're experiencing information security incident which was initiated through your app using attack surface of your application? The source code of this app was secure, but you've got the incident. How could such an outcome be possible, even when you have seemingly done everything right? following the conventional practices. Let me walk you through how exactly we came across this particular issue. While our team was really hard at work on new release tasks for the scanner development, we were currently conducting a research project involving various applications. And this research employed black box testing on production applications, or like binary app. Our team was running binary SAS checks, binary. I would highlight that this was binary SAS checks, not source code. And after we were running these binary SAS checks, we compiled a list of different vulnerabilities. And subsequently, we aimed to match the vulnerabilities in the production app with the vulnerabilities identified through conventional source code testing practices. And here, much to our surprise, the results showed significant inconsistency. And we were really surprised. Some of the vulnerabilities uncovered by binary testing of production apps were absent from the results of our source code testing. So we scrutinized this case again and again, revisited it several times, until we arrived at the conclusion that inconsistency was not due to our errors, but it was caused by compiler itself. It turns out that we are not the first to encounter this issue. In fact, you'll discover, if you go to Google, you'll discover numerous scientific articles addressing this very matter. And in simple terms, a compiler is just a piece of software. And like all software, it's not infallible. It can introduce errors during the process of converting your source code into the production application. And when this happens, there is no way to detect these vulnerabilities through conventional shift left. So simply speaking, you cannot detect these vulnerabilities just by scanning your source code, because vulnerability is induced on a later stage when this source code is compiled into production app. So compilers, they have potential to introduce rather unsettling vulnerabilities that can place your app in a really precarious position. Two of the most frequently encountered vulnerabilities are buffer overflow, which is well known and very old classical concern, where excessive data can overrun the space allocated for it, and it potentially may lead to unintended consequences. And the second one is a side channel attack, which covertly exploits the implementation of your system, revealing sensitive information based on observable behaviors rather than its explicit output. So before we go further, before we dive deep into cyber abyss, let's make this interactive. I've got a quick challenge for everyone here. So please raise your digital hand by participating in our quick poll. Let me run it. So the poll is, have you ever witnessed a vulnerability that you had not detected in the source code? Please give us your vote. Let's give it some time till the poll is going. Okay. Very interesting. Thank you so much. Let me check the results. Yeah, thanks a lot for actively participating in the poll. Well, as I see, it's intriguing to see that the topic of today's webinar, it seems entirely new and previously undetected by many of you. You know, this is the very essence of our motivation behind hosting this webinar, to let you see some unexplored intellectual terrain in application security, which comes beyond conventional application security practices. So let's now continue our discussion. As we have previously emphasized, there is no effective way to spot vulnerabilities induced by compilers by just checking your source code. So what options do you have? Conventional practices would steer you toward dynamic application security testing and sandboxing. But certain types of vulnerabilities would still remain elusive for you. The most promising automated approach that you may employ is a binary scan or binary static application security testing, which utilizes SAST, but not on the source code. It uses SAST on a binary level. So when you identify vulnerability within production application or binary application, your next step is to figure out how possibly you can remediate it. The good news is that by making slight modifications to the source code in specific areas, you are likely to prevent the compiler from introducing this vulnerability again. And we ran some tests, and these tests have proved this. In fact, you have various approaches at your disposal for conducting such testing. And today we'll provide you with some practical insights on how to utilize binary application security testing to detect these vulnerabilities. All right, it's time to pass the mic to someone truly exceptional in the realm of application security. And let's give a big warm welcome to our senior security analyst, the brilliant Miss Valerie Kim. Valerie, the floor is yours.
Yeah, hi, and thanks so much for the intro. I'm here with the DareScanner team, and I'm going to show you how exactly do we run the static analysis when it's binary by using our tool. And to make this a bit more exciting, let me just show you how it works by sharing my screen. So, this is our pride and joy, the DareScanner. And it's a tool that encapsulates multiple approaches to application security testing under one umbrella. Since today our focus is binary SAST, let me tell you how it's done. So in their scanner, binary SAST is included into a static analysis module. And as a tool, their scanner provides both incredible results, which are actionable, and an ease of use, even for those who are not that well versed in development themselves, or perhaps security officers, or someone who's just getting started with application security. So initiating a scan with their scanner is a really straightforward task. So we just choose static analysis, and here I have some executable file, which I just drag and drop here. And why is my touchpad not working? Yeah. And then I just click Start Scan. And that's basically all it's going to take for their scanner to initiate the analysis, but my session expired, so let's do that one more time. So while the scan is in progress, let me show you the results of the same application which I have pre-scanned to save us time for questions or some other juicy details. So as Dan already showed, when we have the executable file scanned by their scanner, what we provide is like some general idea of the security of the project. And of course, the most juicy part comes with the detailed results, the things you can actually do to ensure that you fix the vulnerabilities you encountered and the security of your project stays intact. Thus, let's move to detailed results and give it some time. So in their scanner, the vulnerabilities you encounter in any project of any type of analysis will be grouped by the criticality level. And of course, like the biggest red flag for you, things you want to focus on most, come within the domain of critical vulnerabilities. So if you go here, you can actually click on different types of vulnerabilities to sort all of the entries by their criticality level. And the entries of those vulnerabilities will be grouped accordingly to the vulnerability type. Let's go somewhere like here. And here's where other advantage of using their scanner for running binary SAST comes. So since we were running machine code, bytecode, you won't actually know where the vulnerability occurs unless you implement the decompilation and deobfuscation of the machine code back to the terms of source code. And that's exactly what their scanner does, allowing you to not only detect the vulnerabilities in bytecode, but also match them to the vulnerabilities in terms of source code so that you can actually take action to prevent these vulnerabilities from ever occurring again. So here's what it's going to look like in the interface. In the upper right corner, you're going to have the piece of code where the vulnerability occurs. And regardless of the executable file that you feed to their scanner, you'll still have this internal representation. And in the bottom right, you're going to have all the information you can possibly need to treat this vulnerability and to make sure you never make those vulnerabilities occur again. So namely, you have the description, example of how the vulnerability occurs, some actionable insights on how to tackle that particular vulnerability, links to some other info to get you more information about this vulnerability, some research papers, or just articles from security organizations around the world. The mapping to items which this vulnerability is a part of when we're talking about utilizing security tools for compliance purposes. And another amazing part about running binary assessed with their scanner is that you can not only see the vulnerability in terms of source code, but you can actually follow how the data flows in your application, which leads to the vulnerability. And it's interactive. Other than that, nothing much, just vulnerability management. Let's say you look for the file, you think that this issue is not a particular big issue for you specifically because it's stored somewhere safely. You can always decide to change the criticality of the issue or leave a comment, and it will be safe for any subsequent scans, which you might be running with their scanner. Since we've already touched the topic, another thing is that while we are implementing security strategies in our software, primarily to ensure that the software is safe and secure, another thing which might be especially important for you if you're dealing with sensitive data, like payment data or just personal data of your users, is compliance. And currently, their scanner supports 11 security standards from organizations around the world, some industry-specific standards like PCI DSS and HIPAA. And we try to keep them as updated as possible and successfully beat our competition in the market in that regard. So that's something we take pride in. Thus, if you wish to, you can sort these security issues encountered in your project by any of these standards and produce the results that are applicable to that standard. Focus on them right away, but please still address the issues that remain after you're done with that. And that's basically it on running binary assessed with their scanner. Let's see how's the scan going. And it's already scanned, produced the same results. Who would have guessed? And to quickly wrap it up, another thing that you might be interested in is running scan of your mobile app when you don't have access to your source code. This is also something that you can do with their scanner and also in just one click. So if you don't have access to the source code or just want to check it just in case, what we actually have is running a scan with just a link to your application on Google Play or App Store. And you see, for some reason, it's giving me error now, but also something I've done previously. And normally, all you have to do to run a scan is just to have the link to the app, and it will suffice. And will also give you the results, which can bring you actionable insight into the security of your project. So that's the same app. And if we go to just any instance, you see it's the same thing as we saw on previous project. We have mapping to the terms of source code and some ideas on how to tackle that particular security issue. And that's basically it. And with that, I think I'm ready to pass the baton back to Dan. But let me see how it's actually done. Yeah, all good.
Thanks for the nice demo, Valerie. Thank you so much. And as we're near the end of our webinar, let's reflect on some key takeaways. Number one, as you see there, while shift left approach is crucial in our early vulnerability detection, it works just for source code detection and it may not uncover all potential threats. Number two, compilers can introduce vulnerabilities that are really challenging to spot in a source code. And that makes binary scans as well as DEST and sandboxing a valuable addition to your application security practice. Number three, if you identify a vulnerability in your binary or production app, modifying the source code in some specific errors can actually prevent a reoccurrence of this vulnerability in your production app. Number four, we advise you to consider shift right too, not only shift left, or consider exploring also different testing approaches for production apps, including binary analysis. And number five, continue to stay informed and adapt your security practices, application security practices, on top of what conventional approaches give you. So in this case, you would be prepared to address evolving and new common threats. Thank you so much for joining us today. I think we can jump into our Q&A session. So please feel free to ask any questions. Feel free to share any of your thoughts. Okay, the first question. It was on the demo that there are different tabs with modules such as SAST, SCA. Are they related somehow or just working on their own? Thanks for the question, Stacy. In their scanner, we did our best to make all the modules such as SAST, DEST, MAST, which is mobile application security testing, and binary SAST. All of them are cross-correlated between each other. So the simplest example is you can scan your web app using a source code scanning module, SAST, using, let's say, DEST. You can just enter the URL of your web app, and you will get correlated results. So the scanner would tell you that some of the vulnerabilities were detected by both engines, in our source code and in dynamic scan. So, any more questions? How is your scanner licensed? So the licensing model is very simple. We have two offerings, and they're coming as a software as a service, as well as we can deliver completely on-prem solution, which doesn't require any internet connection. And they're priced either by number of scans included into your license package, or they're licensed with no limitations to users, projects, or lines of codes, etc. The only limitation is by time. So normally it's either by scans or subscription-based offering. Okay. All right. Thank you so much for attending our webinar. And to conclude it on an interactive note, we have prepared a brief and insightful poll. Your input is really invaluable for us, and it allows us to better understand your perspective and needs. And we also would love to hear your feedback to improve ourselves further and see how we can provide even more value for you. Please kindly take a moment to fill out our exit poll, and have a great day.